Good morning, students. Students, in our previous lecture, we discussed something about the electrode potential. And I told you that it is not possible to determine the electrode potential of a single electrode. To determine the electrode potential of a single electrode, it is to be connected with another electrode whose potential is known to us. And that electrode is known as a reference electrode. Am I clear? So it is not possible to determine the electrode potential of a single electrode. It is to be connected with another electrode whose potential is known to us, and that electrode is known as a reference electrode. Now, as per our syllabus, student, the reference electrode which is to be discussed is standard hydrogen electrode, which is abbreviated as SHE, or normal hydrogen electrode, which is NHE. Now, in the board examination, it may be asked to discuss something about the standard hydrogen electrode. Now, standard hydrogen electrode is a reference electrode. It consists of a copper wire which is attached to the platinum black. Am I clear? Now, this is being surrounded by the outer glass jacket, which have an inlet for a pure and dry hydrogen gas. This entire setup is being kept in the acid solution whose concentration is 1 molar. So, 1 molar acid solution has been taken over here. Now, what is done? When pure and dry hydrogen gas is passed through 1 molar acid solution at a temperature of about 25 degrees C, some of the hydrogen gas get adsorbed on the surface of a platinum wire, on the platinum black, while some of the hydrogen gas get dissolved in the acid solution, due to which there develops a potential difference between the metal electrode and the solution. And that potential difference, in the case of standard hydrogen electrode, will either be oxidation potential difference or reduction potential difference, depending on the fact with which electrode it is connected with. And experimentally it has been found to be 0 volt. So here, student, when the hydrogen gas, pure and dry hydrogen gas, is being circulated through the acid solution, there exists an equilibrium between the hydrogen gas and the hydrogen ion. Between the hydrogen gas and hydrogen ion. Now, at 25 degrees C, the standard electrode potential for hydrogen electrode has been found to be 0.00 volt over here. Fine. So, the standard electrode potential, in this case, for reference electrode, is standard electrode potential. Standard electrode potential over here has been found to be plus minus 0.000 volt. Am I clear? So, now, when this standard hydrogen electrode is connected with another electrode, it may act as a anode and it may act as a cathode. So, we may say that the Shear half reaction, if you write down over here the half reactions of Shear half reactions, and the electrode potential value. Shear half reactions and electrode potential. Shear half reaction and the electrode potential value. How will we go with this? In the Shear half reaction, this hydrogen will be losing the 2 electron and will change into the hydrogen ion, and 2 electrons will be given out. And the standard electrode potential of this has been found to be equal to 0.0 volt. Here again you may put it over here as 0.0 volt. Means 0 volt, 0.0 volt. And this will be called as an oxidation potential. This potential over here will be known as a oxidation potential. Am I clear? So, what do we call this potential? We call this potential as oxidation potential. Now, when connected to the another electrode, whose electrode potential is to be determined if it undergoes the process of reduction, in that case this hydrogen ion will gain the 2 electron and will result in the formation of a hydrogen gas. And here again the electrode potential will be 0.0 volt. And this over here will be called the potential, which will be called as a reduction potential. This will be a reduction potential. This potential over here will be called as a reduction potential. Here it is undergoing the process of oxidation. So this electrode over here will be acting as a anode. So what will be this? This will act as an anode. Here it undergoes the process of reduction. So this will act as a cathode. I think I shall be very, very clear, student, over here. So just try to recollect what we are trying to do. We have to find out the electrode potential of a single electrode. And as I already told, it is not possible to determine the electrode potential of a single electrode. So how do we determine this? We need to connect that electrode with another electrode whose electrode potential is known to us, and that electrode is called as a reference electrode. As per our syllabus, that reference electrode is a standard hydrogen electrode, or we may call it as a normal hydrogen electrode. What is standard hydrogen electrode? An electrode which consists of a platinum wire coated to the platinum black or the platinum rod over here, which is being surrounded by the external jacket which have an inlet for a hydrogen gas. Now when from here we pass the hydrogen gas, some of the hydrogen gas gets adsorbed on the surface of the platinum black, while some of the adsorbed hydrogen gas dissolved in the acid solution, due to which there develops a potential difference between the hydrogen and the acid. That potential difference is called as the electrode potential. In the case of a hydrogen gas, when connected to the another electrode, it will act as either the oxidation half, so that means it will act as an anode. Here the electrode potential will be taken as 0.0 volt, or it will act as cathode, that means it will undergo the process of reduction, and here the electrode potential will be taken as a 0.0 volt. Fine. Now you must remember these standard values of electrode potential. Now the question is, how do we determine the electrode potential of a single electrode? I will try to explain this to you by finding out the electrode potential of a zinc and copper electrode which were used in the Daniell cell. So determination of, if you want to determine the electrode potential of oxidation half, determination of standard electrode potential of, determination of standard electrode potential, determination of standard electrode potential of zinc 2 Zn2 positive electrode. Determination of the standard electrode potential of zinc 2 positive electrode. Am I clear? How do we find out the electrode potential of this electrode? Now, what we will do? We will construct a galvanic cell in which one of the electrode will be a zinc electrode, other electrode will be the hydrogen electrode. So how we will find out that electrode potential of this? We will take a half cell. In this half cell, we will have a zinc electrode. We will take a half cell. Here in this half cell, we will have a zinc electrode. Then we have another half cell in which we have the hydrogen electrode. We have a zinc electrode and a hydrogen electrode. This hydrogen electrode will be having a platinum this wire which is coated to the platinum black and is being kept in the acid solution, which is being kept over here in acid solution. You may see over here, student. Here, this is for hydrogen gas. Now, how do we do this one over here? This electrode of a zinc is connected with the another electrode with the help of a voltmeter. How? So we'll connect this and connect this with the help of a voltmeter. With the help of voltmeter, we will connect these two electrodes. With the help of this, we will be connected and connected to a voltmeter. The internal connectivity between the two half cells is being provided with the help of a salt bridge. It is provided with a salt bridge. This is being kept in the zinc sulfate solution. What we have to do, student? We have to find out the electrode potential of this. This is zinc sulfate, which is 1 molar. Here it is being kept and kept in the acid solution, which is hydronium ion. And this again will be 1 molar. Here from this side, we have passed a gas. The name of a gas is hydrogen in the form of a gas, and is being passed at 1 atmosphere. This internal connectivity is being provided with the help of a bridge, which is called as a salt bridge. Am I clear? So what is the aim of ORS? We want to determine the electrode potential of a zinc electrode. This is zinc electrode. And this of course is a hydrogen electrode or Shear. Now we all know that standard electrode potential of Shear, whether it undergo oxidation or reduction, will be 0.0 volt. Now when these two are connected with each other, what is observed? That the flow of current in the voltmeter is found toward this side. Flow of current is found toward this side. Am I clear? It means the flow of electron must be from this side to this side. This is a flow of electron. It means the zinc electrode has lost the electron and undergone the process of oxidation. So what happened over here? Zinc will be losing the 2 electron, and it will result in the formation of a zinc ion, and that over here will be the process of oxidation. This hydrogen electrode will be gaining the 2 electron. Hydrogen electrode will gain the 2 electron, and on gaining the 2 electron, it will change into hydrogen. Am I clear? And this is a reduction half. This is a reduction half. So zinc undergoes the process of oxidation, hydrogen undergoes the process of reduction. Now if we write down over here the cell reaction will be zinc will be gaining the hydrogen ion or reacting with hydrogen ion, and will result in the formation of zinc 2 positive, and hydrogen will be given out. Hydrogen electrode will be given out. Then in this case, we have to find out the electrode potential of a zinc electrode. There, student, we will be using the formula for finding out the EMF of the cell. How do we do this one? Always remember, EMF of the cell, electromotive force of a cell, will be equal to E naught oxidation plus E naught reduction. Here the oxidation will be of zinc. So this will be E naught of zinc to Zn2 positive ion plus E naught of hydrogen ion has undergone the process of reduction to this. Am I clear? Now see, we have to find out the electrode potential of a zinc electrode. For hydrogen electrode, what is the reduction potential value as per this equation? It will be 0.0 volt. Now when we measure the EMF of the cell, experimentally the EMF of the cell in this case has been found to be equal to 0.76 volt. So this EMF of the cell comes to be 0.76 volt. This will be equal to E naught oxidation zinc to zinc 2 positive ion plus 0.0 volt. So we find out over here that E naught of zinc 2 positive ion, this will be equal to 0.76 volt. So this is how the oxidation potential of a zinc electrode is to be determined. Suppose someone asks you that if you are asked to find out the reduction potential of this, reduction potential of this will be written as this way: E naught zinc 2 positive to zinc. The sign convention will change and it will come out to be equal to minus 0.76 volt. This is how the electrode potential of this electrode is to be determined. So what we are trying to do today, we are trying to find out the electrode potential of a single electrode. How can we find out the electrode potential of a single electrode? By connecting with another electrode whose electrode potential value is known to us, and that electrode is a reference electrode, which is Shear or standard hydrogen electrode. Now when connected to the zinc electrode, zinc undergoes the process of oxidation and hydrogen over here undergoes the process of reduction, and EMF of the cell is found to be equal to 0.76 volt. Putting in the formula, we find out the oxidation potential of a zinc. Am I getting clear? So you may see over here that the electrode potential of a zinc electrode is determined by connected with the standard hydrogen electrode. Now suppose now we want to find out the electrode potential of a copper electrode. So determination, this experiment is clear, student. In the Daniell cell we have a zinc electrode and a copper electrode. Zinc is done. Now if we go for another discussion, this is determination. Determination of reduction potential of copper. So determination of standard electrode potential. Determination of standard electrode potential of copper 2 positive to copper. Determination of standard electrode potential of copper 2 positive to copper electrode. Now listen over here, student. How do you find out this value? Determination of standard electrode potential of copper 2 positive to copper electrode. Here again we will take the two half cell. One will be connected to the positive terminal, other will be connected to the negative terminal of the battery. This will be again over here the two electrodes. Yes, in one of the electrode we have a zinc electrode. Then in another electrode we have a hydrogen electrode which is connected to the platinum black. Fine. Then this will be this electrode. This over here is a hydrogen electrode. From here we may pass the hydrogen gas. And then they are connected to the copper electrode. These are connected and connected to the copper electrode by connecting with a voltmeter. By connecting with the voltmeter this way. Yes, internal connectivity between them will be provided with a salt bridge. Here this is being kept in a solution of copper sulfate. This is copper electrode, and this copper electrode is being kept in copper sulfate solution. It is being kept in copper sulfate solution, which is 1 molar solution. This over here is the hydrogen electrode, which is being kept over here in 1 molar hydronium ion. This is platinum black. From here the hydrogen gas is passed at the pressure of 1 atmosphere. Now when the cell circuit is complete, it is observed in this case that the flow of electrons occurs toward this side. It means from copper towards flow of current is from copper towards the hydrogen electrode. It means the flow of electron will be from this side to this side. So it means this half will undergo the process of oxidation, and this half will undergo the process of reduction. Am I clear? In oxidation half, this hydrogen will be losing the 2 electron to form the hydrogen ion, and 2 electron will be given out. Then the copper will be gaining the 2 electron. Copper 2 ion will be gaining the 2 electron and will change into copper matter. Overall, we will write down the cell reaction. Here, E oxidation of hydrogen to hydrogen ion, so is found to be 0.0 volt. Here, E reduction of copper to copper, it is to be found out. We will sum up the reaction. This electron will cancel up. What will happen? This will be hydrogen plus copper ion, and this will give us the hydrogen ion and copper. Am I clear? So hydrogen undergo the process of oxidation, copper undergo the process of reduction. Now if we measure the EMF of the cell through this voltmeter, it has been found to be equal to 0.34 volt. This is voltmeter. It is found to be 0.34 volt. So over here in this case, EMF of cell, this will be equal to E naught oxidation plus E naught reduction. This value has been found to be 0.34 volt. Oxidation is of hydrogen electrode, H2 to hydrogen ion. Then reduction is of copper 2 positive to copper electrode. This is 0.34. This standard value will come to be equal to 0.0 volt plus E naught of copper 2 positive to copper. So what do we find out? The E naught of copper 2 positive to copper electrode, the value will be equal to 0.34 volt. So just see, we have been able to determine the reduction potential of a copper electrode. Am I clear? So reduction potential of a copper electrode has been found out. This is how the electrode potential of a single electrode can be obtained. Zinc was 0.76. Suppose someone asks you to find out the oxidation potential. So how do we find out the oxidation potential of copper? As per the sign convention, copper to copper 2 positive will be equal to minus 0.34 volt. Minus 0.34 volt over here. Am I clear or not? Yes? So this is how it is to be done over here. So student, in this lecture today, we have tried to find out the EMF of the electrode potential of a single electrode, either the oxidation potential or the reduction potential. For the oxidation potential, we have found for the zinc and copper. So this is how a single electrode can help us in determining the electrode potential. How can we determine? By connecting with the reference electrode. So I think, student, you must have understood this. How to find out the electrode potential of a single electrode? Of course, by connecting with the reference electrode, and that reference electrode is the standard hydrogen electrode. Hopefully you must have understood. We will meet again in the next lecture. Till then, thank you.